our agenda today is to explain a few statistical concepts. Main concepts being that of standard deviation, histogram, normal distribution, and then onto the indexes for process capabilities. We will talk about variation and its causes. We will also talk about specific indexes like CP, CPK. We'll talk about process performance index, PP, PPK. And we will also talk about something about machine capability, which is CM, because these are the most commonly used indices which are used by most of the people in industry. So achieving world-class manufacturing is the goal of many manufacturing companies all over the world. And what it means to be world-class. So if you think about world-class companies, in the automotive sector, you might think about things like Mercedes-Benz or Toyota. The other sectors also, you can think of some names like IBM or Dell. In the service industries, is Google and so on and so forth. One thing common with all these world-class companies is that they are conscious about their targets, which are that of quality as well as cost. So world-class companies are those which have eliminated non-conforming parts to go to their supplier, to their customer, sorry. So no non-conforming and no defective parts should ever go to their customer. This is the first and most important thing. But is this enough? Because what it means is that if your company, of your process is producing non-conforming parts, then obviously there is a variation in the process, and that variation in the process needs to be reduced so that you only produce conforming parts and not non-conforming parts. So this is the next step that all companies have taken historically. And today, this means that you are controlling the process, and by controlling the process, you are meeting your target for cost and quality. And this also means that quality and cost targets require you to have process control. There is no point in giving a Mercedes-Benz car to a customer who wants an Alto, for example. It makes no sense whatsoever. So what does the customer decides? What is the cost at which he is willing to pay for the quality that he wants? So these are the two major criteria of satisfying the customer for any world-class manufacturing process. So if you look at manufacturing excellence or achieving world-class, it is basically a journey. It's a journey from eliminating the production of non-conforming parts to that of controlling the process so that non-conforming parts are not produced at all. So this is the journey that all these companies have taken. Different methodologies have been used, and you must have heard of so many of them. Today, we are going to talk more about the statistical process control, or SPC, and we are going to talk about some very basic ideas about process capability. So it's a very basic presentation that is going to be there today, which will try to clear all your concepts of process capability. So how does one produce quality, or can one produce quality? The answer to this question is that you cannot produce quality. You can produce parts, you can produce components, but you cannot produce quality. So quality is an output of a process. Quality is, there is no direct control for quality. So quality means that you need to have a process that produces parts to the required quality. So quality is quality is not an end product in itself. And the variations in the process results in variation in quality. So if you want to really look at your quality, you really need to look at your process. So process control is what drives quality control. So this is the main thing that we need to remember. Now, most Indians, most of us, one of the most favorite things that we all look forward to are the cricket matches. I'm sure in this audience, there are a lot of people who are following cricket. So we will use that as an example. And one of the iconic cricketers that all of us know is our friend, Mr. Sachin Tendulkar. So let's see what Sachin did in the last 9 innings that he scored. So for example, these are the things that he scored. So these are the various scores that he has scored, right from 40, 56, 38, 38, 63, 59, 52, 49, 46, etc. Now, suppose Sachin were to bat today. What is he likely to score today? This is the question that is in my mind. So one of the things that you possibly can do is say, okay, let me see what is the average of all these scores. So average, if you want to look at average, we can find out the average. The average happens to be 49. But okay, 49 is his average. So maybe he will score somewhere around the average. But what is the distribution of the scores around this average? We might want to have a look at that. In which case we sort out these numbers. Okay, the average in our language, which we are going to use subsequently, we will call it as x bar, where each of the numbers is x1, x2 up to n divided by the number of numbers, which is n. X bar is the average that we talk about as we go along. That the next thing I can see, how is the scores distributed? So for that, we can sort the numbers out in ascending or descending orders. And we find that interestingly, this 49 also is somewhere in the right in the middle, because we have taken the 9 numbers, we've got this as a 5th number right in the middle. So in this particular example, the average or the mean, as we call it also, and the median or the middle point of these numbers is the same. So this is our median. Now, is there anything further that we can do to find out what is he likely to, what is the probability of what he is likely to score today? So we say, okay, let's have a look. So let us find out what is the distance of each score from the average or mean. So for example, the first score was 40. So 40 minus 49 would be 9. And we take the absolute value of that. And we try to do that for all the numbers. And this is what we get. So we've got the distance from the mean for all the scores that have been scored. And then we say, okay, fine. So this is the distance. Maybe what we can possibly do is take the average of these. So we can say, okay, let me take the average of these numbers, and that happens to be around 7.56 or rounded up to 8. And most of us, or all of us being engineers in some way or the other, we like to add a tolerance. So we say, okay, what is the probability that this Sachin is likely to score 49 plus minus 8, or the average of the difference? And we say, okay, this looks like a very good way of probably estimating what Sachin is likely to do. So some of the deviations of the readings divided by the number of readings. And if you square them, because in some cases it would have been negative number, and some it would have been positive. So one of the ways to handle that situation is to square it. So we square those differences and then divide by the total number of numbers. And then finally, this is what we call as variance. And finally, we take a square root of that, and that we call as a standard deviation. And this, in this particular example, happens to be 8.73 or around 9. So we say, okay, well, wonderful. So now we have got a situation where we can say, okay, the deviation from the mean, his mean is around 49, and the deviation from the mean is around 9. So 49 plus minus 9. So between 40 and 58 is what our good friend Mr. Sachin Tendulkar is likely to score today, is what we can probably conclude from this short exercise. Now, if this exercise was actually done over a long period of time, throughout his career, what scores he had, and we were to do this exercise and plot this. Now, this diagram that you see in front of you is a plot of the frequency. So for example, we say, okay, between 0 and 5, how many times in the career has he scored? Between 5 and 10, between 10 and 15, and so on and so forth. We plot this cumulative frequencies, the frequencies of each of his scores in a range, and how many times he has done that. Then we might get a graph which might look something like that. And then we look at the area under the graph and we say, okay, if we take in this graph, if we add 3 standard deviations to the mean and subtract 3 standard deviations from the mean, we might get a situation which looks like this. And this situation is what we call as a normal distribution. And we find that the area under this graph, if you take 1 standard deviation, which is here, then you find that in that 1 standard deviation, the area is around 68%. That means 68% of the time, Mr. Sachin Tendulkar, based on his past history, scored within his mean plus minus 1 standard deviation. And then if we take 2 standard deviations, then 95% of the area, probability is that the 95% will score minus standard. And if we take 99.73%, that means if we take 3 standard deviations, then the area under the graph is 99.73%, which means that we have now got some kind of a probability distribution of what is he likely to score. So this is how the normal distribution is defined. It's defined as a distribution which is symmetric. It is defined as a distribution wherein if you take 3 standard deviations on both sides of the average, it would cover 99.73% of the area under the graph. And if you would take plus minus 2 sigma or 2 standard deviations, it would cover 95%. And if you take 1 standard deviation or 1 sigma as we call it, it would contain around 68% of the area under the graph. And that distribution is called a normal distribution. It's also called a Bell distribution. So it's a Bell graph or a normal distribution. Now, there is a caveat to this, and this distribution is normal provided that there is no special cause or something special happening in this distribution. And so we are going to understand what those things are in the next few slides. So what would Sachin's probability be in such a situation? So in such a situation, 68% of the time his score would be between 40 to 57. 95% he is likely to score today between 32 to 66. 99.73% he is likely to score between 23 to 75. But there is a 0.27% chance that he will score less than 23 or greater than 75.